Welcome to Chapter 15, Metadata. What is metadata? The short description is data about data. And in this case, metadata is information about a dataset. It is prepared to help users understand and apply the data properly in our maps. The metadata contains information on the structure and meaning of the data. It cites the sources and credits for the data, access and use constraints. It may be part of the data set or an additional item to it. We're going to look at it as part of the data set. And it may be stored in data warehouses to help users search for data sets, such as on WAGDA. When we go to WAGDA, you will see that there is a metadata tab to get the metadata before you even bother downloading, which is very helpful. Metadata, United States generalized. It'll give information such as the data format, the file or table name, the geographic coordinate system, in this case, the coordinate system, geographic, and also keywords such as polygon, area, demographics, population, etc. The interesting thing about metadata is it's still going through a major change. In fact, our software has been updated since this book was produced, so this is going to be a very quick chapter. What we do in your lab will be sufficient for understanding metadata in this course. These are some metadata examples. You will be looking at these in the ArcGIS metadata. And for that, we can use the lab, so I'll continue here, but just notice these samples. Metadata standards. The FGDC, Federal Geographic Data Committee. They define and manage the standards for metadata. And one of the big issues with ArcGIS 10 is they didn't include this automatic updating process for the FGDC metadata. So a lot of people were up in arms about it. You can find out more by going to the link provided at the bottom of this page. This is a Don't Duck metadata guide. It's pretty much explaining that you need to use metadata to keep information about the data with the data so it can be used properly in the future. Why is there a standard? And they're listed here. I don't need to read them to you. Pause the slide and read if you wish, but this is why there needs to be a standard, although I venture to say there really isn't a standard yet that everybody's using consistently. What standard? These are different standards for metadata. Goes back to what I said in the last slide. There isn't one that's used across the board, so to speak. Why metadata? I can read these to you, or you can read them on your own. This is why we use metadata. Data quality, again, pause the slide, read these if you like. These are the key points of data quality. 6 data quality issues: lineage, positional accuracy, attribute accuracy, logistical consistency, completeness, and temporal accuracy. Temporal speaks to time, by the way, and there was a question in chapter 15 about, is the data current? And it was in chapter 4, if I recall correctly. But the data wasn't current because it was from 19 something, and we're now in 2011. Lineage, original source of the data and the processing steps that it's been through. This is good when you start transferring data between people. It talks about the source and the citation here. Talks about where it will be best used. For example, 1 to 2400 USGS topo map is the source scale, and that'll indicate where it would be best displayed in your map. Again, we have source scale. At At the 1 to 5 million scale, it's the pinkish color, and 1 to 25 million scale, you can see how it's very rough edges. And it makes a difference on what we use. If we're looking at the whole United States, the 1 to 25 million might work. If we're drilling down to Massachusetts and Rhode Island, as we're looking at here, 1 to 5 million would be much more appropriate. Findings, source scale, you can read this. It's really easy to find in your document. The lineage, everything that it's been through, you'll notice that we don't touch on it that much in the lab, but you will notice that the data has been processed and it keeps updating itself somewhat. Here's some more lineage examples. There's no need to read through those. It's just an example. Positional accuracy is an assessment of how closely features in a data set correspond to their actual positions in a real world. And you can see where this is important. The road or shapefile line is not very accurate to the road, the actual image of the road. Geometric accuracy, is it where it says it is? In this example, they're showing a road at the very top, and there is no road actually on the ground. There's also a house or garage here, and there isn't one right here. And here we have a road and also the real road. One's a shapefile, one's an image. Precision, the number of significant digits. Statistical variability of a repeated measurement. They're not the same as accuracy. GPS unit reports location to the nearest meter, so that's a precision of 1 meter. If you have 20 GPS measurements at the same spot, they would probably have a standard deviation of about 5 meters. The precision is about plus or minus 10 meters then. So more on scale and position. We don't need to get into that at this level. National Map Accuracy Standards. It's good to read, but no need to get into it in this depth at this point. Map accuracy. In practice, few maps are actually tested. A lot of the times we're not building descriptive maps in terms of driving particulars. We're using attribute data to make maps, as we've done in the labs. Practical rule of thumb assumes a typical line width on a map is 0.5 millimeters. Map scale of approx 2000 gives them approximate precision in meters. So 1 to 5000 is 2.5 meters, 1 to 2400 is 12 meters, 1 to 100,000 is 50 meters, and 1 to 1 million is 500 meters. Remotely sensed data. Accuracy varies depending on the original capture resolution by the instrument. And we're not going to get into that much remotely sensed data in this course. Processing effects. Talks about the errors. Most of this is pushing for good metadata. And it's true. Metadata is necessary and it should be used. Right now it's not used as much as it should be in practice. RMS error we're not going to discuss. Using tolerances we don't need to discuss at this point. Some more accuracy information. Attribute accuracy assesses how well the attribute values correspond to the values in the real world. The point of a lot of this is why we need it again. However, a lot of times we're stuck with the data that we have. And there's a saying, something to the effect of, good data is data that you have. And you just have to deal with the faults that it comes with. Thematic accuracy, how accurate are the attributes? This tells us Again, why we need to have accuracy, and it needs to be in there. We talk about measurement errors. What is the precision and accuracy of the instrument used to record the data, the GPS unit, and or the forest canopy by visual? How measurable is the phenomena? Is the geologic contact visible or inferred? Can the census count every person? This goes to where populations are estimated. Classification issues. How fine was the original measurement scale? Are the measurements the original values, or have they been classified? And we'll do some classification. Do the class break values influence the distribution, and by how much? How often do mistaken measurements occur? Hopefully not a lot, but in practicality, in practical sense, sometimes they are. Assessing attribute accuracy, still campaigning for metadata. Logistical consistency, this is an important issue where these two shapes should line up. There should not be any gap in there. Here we have what could be road features where this is an overshoot, this is an undershoot. Two lines, if they connect, they should connect at a node. This is probably an improper intersection if you could turn from orange onto green. If this is a bridge, then that's perfect. And a loop, unless this is a bridge right here, there should be a node right there. Topologic rules, we notice there's Nebraska here and South Dakota. They should line up between South Dakota and Nebraska, and also the counties should also line up. There should not be any random space, and you can read the rest of the items of the slide, but that's the general gist of what we're getting at. Again, data quality, we can move on. Completeness, is everything filled in? Is there areas of no data? And what do we do with areas of no data? Some more on completeness. I just spoke of that. Some more completeness reports. Temporal accuracy. Is it still current in the ground conditions? Weather is probably a great example where it's not very current. As soon as you hear it, it's old. Data change scales. You can read through this and look at some of it in the book, but there's virtually invariant geological maps, digital elevation models, decadal scale, such as land use, vegetation maps, earthquake maps, a yearly scale, which would be census data perhaps, drought index, crop production, and ephemeral, which would be NEXRAD radar, daily temperature, always changing, moving up to almost never changing as we move towards the top. Updates. Talk about the update frequency, once only publication or updated regularly. Still lobbying for metadata. Metadata format. This is metadata divided into 7 main sections, and they vary by standard. Identification, data quality, spatial data organization, spatial reference we will be looking at in Pacific Northwest Lab 3, and entities, distribution, and metadata reference. Here are the sections. It describes what each of them are. You may pause the slide and read those. You also probably read that in the book. Identification, what kind, where did it come from, what is it for, and who can use it. Here's some more. Here's a sample of some identification information. Key items. You can pause and read these if you'd like. Data quality. You may pause and read that slide. Here's what it looks like in the actual metadata, and you'll see that when you complete the labs. Key data information, as we spoke of earlier. You may pause and read those if you like, or take notes. Data organization section. Again, ArcGIS fills out this section automatically. Includes info on the type of data and how it's stored. Spatial reference. We use this quite a bit to determine what we've got when we look at our data. So we'll be referencing that ourselves in the labs. Entity and attribute. This tells us, this is very helpful when you're getting a new piece of data, to look at it and find out what the attributes are. What does the code 1 mean? What does code 2 mean? Those can mean distinctly different things, but it may not be readable in the data, such as land use or land cover. 0 may be water and 1 may be parking lots. Until you look at the code, you don't always know. And that's why it's important to look at metadata. We use the attribute metadata quite a bit. Here's some examples. It talks about the attribute labels of death and its alias of death, and then the definition. The deaths attributed to the earthquake either directly or indirectly. And here's another attribute labeled depth. The depth of focus in kilometers of the earthquake. A value of 0 may indicate the depth is not known. That's why this, and there's an attribute info for every attribute, ideally. Here's some key points, overview description, and a detailed description. You may want to pause and take notes on that section. The distribution section, who distributes or sell, that's how you would figure out where you're going to get the data or get permission to use it. The format, the costs, etc. This is actually one of the questions in the chapter. What section do you go to figure out who sells the data or how much it is? Here's a distribution sample. This is what it would look like. This is who you would contact for this data. Key distribution fields talks about the distributor, the format, the process, and the available time period. Reference section, the format of the metadata and who develop it. Most forms are filled out by ArcGIS. It's dynamic. It changes on the fly with what happens to the data. Metadata reference example we were just talking about again. There's another slide of it. Key terms, contact, format, and distribution restrictions if there are any. Acquiring metadata. History. Metadata has been around for a long time, but the tools have not always been there to use it. And not all organizations use metadata that is automatically copied and stored with the data sets. And many people are guilty of this. It's getting better than, for example, when this was published in 2011, but it could be better, and it should be getting better. Acquiring metadata, source data from other organizations. Most organizations provide it. It's almost necessary, but a lot of times it's not there. And a lot of times you'll see some metadata and then it will say required and it'll be missing. The development of metadata. This is when it develops, when the database development starts, and it collects information on the way. You collect information along the way. If you wait too long, you'll miss something. So it's good to keep it with the data. You won't be creating that much new data, so you won't have to worry about this too much. Here's a metadata note record, which could be useful. And then moving to ArcGIS. We have a metadata editor. You'll be using that in one of the labs. three types of storage format right now: text file, XML file, and HTML file. And we find it on the description tab. It'll give a summary, description, and right now we are looking at National Atlas Cities. So it might be on this data set. It's hard. Oh, yes, cities right there. Oregon data cities. It's a personal geodatabase feature class. Here are some styles. We'll get into this more as we look at it. Metadata stored internal ArcGIS format, which isn't always used by everyone, so it gets confusing. Standards based, we will choose a standard. We actually inspire metadata directive for our lab, but there are different metadata standards. We've just chosen Inspire for our use at this point. And you'll see these often in the metadata, ArcGIS and FGDC. Here are the metadatas, what it looks like. In the description, you'll be looking at reference system particularly, and spatial representation. Here's a metadata editor. You will be editing this. You'll see this exact screen in the lab. FGDC Compliance. You may read through these. I won't read them to you. I'm going to pause the video. Mandatory elements for FGDC and NAP metadata. That's why you will see required in a lot of places. Sometimes it's not there. Templates, using a template. Let me read through this. I'm not going to read it to you. An organizational template. This is just a sample. How to create a template. We won't be doing so. Reference map. This gives a little bit of information on who should fill out what. You may pause or make a screenshot of this for your reference. And a cute little slide to end. Metadata, don't delay, start today. Anytime you work with metadata and change things in the data, you should update the metadata. And unfortunately, not everyone does this, and that's why metadata is still one of those items that needs to be enhanced in GIS. And that concludes Chapter 15.